Welcome back to my channel Conquer the Fear. Are you struggling to crack the Java multithreading interview questions? Feeling overwhelmed when the concept of deadlock, synchronization, and thread management come in picture? Don't worry, in this video, we will cover and break down the most commonly asked multithreading interview questions and provide you with the clear answers and give you the confidence to ace your next interview. So, whether you are a beginner or whether you are an experienced developer, these insights will help you to stand out in the interview. So, let's dive in and master the multithreading together. Myself have interviewed many peoples. When it comes to multi-threading, people get freezed up, people get tensed up. In this video is my attempt to make this particular feeling a little bit easy and also make you understand that it's not a big deal. I have segregated this particular video into different sections, so starting from the basics till the advanced. So stay back to look out all these particular interview questions. Now, what is the difference between the synchronization and volatile keyword? Now, when it comes to synchronization and volatile, these are all part of managing your concurrency, and it is trying to ensure that your thread is safe. Okay, but they work in a different way. Well, let's firstly look at the synchronized way. So when it comes to this, it is used to control the access of that particular section of that particular code. Okay, so when your multiple threads are trying to access that particular code, it's going to control that access. Now, when a method or a block of code is declared with synchronize, it is going to ensure that only one thread is going to enter into that particular block and execute that particular method. Okay, so at a given time. So this is has to be a very critical code, and this has to be a very critical situation where it is going to avoid there are different race conditions, right? So when a multiple threads are trying to access some shared resources. Now, how internally it works is that when a thread enters into that particular synchronized method or a block, it is going to acquire that particular lock on that particular object or also the class itself. So depending on whether what method or what synchronization block or the instance of the method, it will take acquire lock. Now other threads which are trying to attempt other into enter into that particular synchronized block, right, or a method, the on the same object, it is will be blocked until that particular code is executed, and then the release of that particular thread happens by the first thread. Okay, so once thread is going to exit, the first thread, second that is going the synchronized block which is executing, it should be released, and it is going to allow the threads which are waiting or to acquire lock on the particular shared resources. Now there are different types of synchronization. One is at the method level, that is instance method level. Now when method is synchronized on an instance, basically, right? Then the like let's say you have a synchronized void foo, right? So it is the lock is all hence on the instance, okay, on the object itself. But let's say you have a static method initial synchronization. Now in this, when a method is synchronized on certain class, let's say you have a synchronized static void. So the lock is held on the class itself, not the object. Okay, the class object of that particular class will be synchronized. Now, block of initial synchronization. So basically, you can synchronize some specific code or a block of the code using the synchronized block. Okay, where you can pass that particular object. Okay, so here is an example which is given to give a synchronized method. If you see, it is using the void and then the increment. So in this, only one thread will enter that particular increment method at a single time. Now, volatile. This is another keyword opposed to synchronization. So when it is going to indicate that the variable which is accessed or which is modified by the multiple threads has the same visibility. Okay, so when a field is declared static, this volatile. Now this is going to ensure that all the threads is going to read from the main memory and not from the thread local itself. Now thread has got two memories, right? It is going to read from the main memory. Now internally, when a variable is declared as a volatile, it is going to guarantee that the visibility across all thread is going to be the same. Okay, only so that is one thread is going to update the value, the other thread is going to immediately have the visibility of that particular thread. Okay, it is not going to be in the local. Now, the only the volatiles, I would say, disadvantage is that it is not going to provide the atomicity. So it is not going to guarantee any operation on that particular variable will complete without any interruption or not, okay, by the other threads. Now this is going to ensure that your read or write in the variable is done directly on that particular main memory. So thread is trying to access that particular data. It is not from their local. So the syntax is private volatile boolean flag is equal to false. Now in this example, the flag is visible to all the threads, and any update which is happening on that particular flag value, it is going to be immediately available to all the threads. Now I've disclosed the same information, the difference of synchronized and the volatile. Now what happens if the thread calls notify instead of notify all? Now this is one of the common questions, and I would say out of 9 out of 10 out of 9, you'll get that particular interview questions when you're dealing with a multi-threading section, okay. So this is an age old question. Now if you look at this, both notify and notify, it doesn't seems to be much difference, but it is used to when to wake up the thread that are waiting on certain objects, monitors. Now let's say the thread that are waiting on the certain conditions to be satisfied in that particular synchronized block or that particular method, that is in that case we use. However, these two methods are very crucial, and actually it has got slight difference, okay, when it comes to managing the concurrency. Now let's first look at the notify method. Now notify method is going to wake only single thread that is currently being waiting on certain monitoring of an object, okay. So one thread from the list of that particular threads, with let's say there are 10 of them, so it is going to only wake up one of them, which are waiting in the wait condition. Now when notify is called, it can pick up the thread from any of this particular waiting queue, and then it will wake it up, okay. So allowing the thread to proceed with its execution. Now it does not guarantee, okay, the thread will be notified if the multiple threads are waiting, okay. So that's the one of the disadvantage. But yeah, one thread only we waked up which is waiting on a particular monitor just will be happy. Now there is an unpredictable behavior. If multiple threads are waiting on that same monitoring, right, it is the thread will get notified. It is undetermined. It will not know. So it could be any one of the thread out of that particular 10 thread. So now, basically, when you're trying, it can also lead to a deadlock or a solution. If a thread is notified, but the condition is waiting for it, it is still to be satisfied. It's not satisfied, let's say. Now it is going to immediately go back to the waiting state only, right? Now, or it may not even make any progress, basically. So potentially, it is will what it will cause the deadlock situation. It is going to start. So that's the disadvantage. Now the syntax is synchronized object and then the object and notify. So this is only invoking only one single thread. Now notify all, it is going to be a again on the, it's a method which is going to on the wake up all the threads that are currently in the waiting state for an abandoned object. Now once that particular method is called, okay, all the thread which are moved to ready queue, okay, from the waiting state. Now when they are complete on that for the monitor to complete that particular execution, however, it does not mean that all the thread will immediately start executing. It will only release that particular from their waiting state, and it eventually it will be allowed to some of the methods to acquire that particular lock, and that certain condition is checked, and then they will be waiting for it, okay. Now, waiting for all the threads are waiting on that object monitor will not be notified in this case, right? Notify method. Now, when it comes to the performance, right? So it is going to ensure that no thread is indefinitely in that waiting state, okay? That a wait definite. So it can notify all. So it may cause a performance issue in this scenario. So where the many threads are waiting. Now all of them will be awakened even if there is only one thread which is going to make a progress, but the rest will again go to their waiting states. So how to avoid this particular avoid this that by notifying all the threads, the system will avoid the particular possibility of threads being in that particular starve mode. Okay, so if let's say a certain condition is not matched up. So this is an example. So we already discussed notify is for say, waking up one single thread at a time, but notify will wake up all the waiting threads to ensuring that they get a chance to proceed. Now this is an important because many people doesn't even know like if there is a method thread dot sleep, and also it is going to acquire a lock or not. It is just going to execute. So what exactly it does internally, we'll discuss in this. Now this is one of the method of thread class. It's a static method. Now thread class is used to either pause it, or it will sleep that current thread from executing the specific at some specific time. Let's say you have some milliseconds or nanoseconds to be defined. It will sleep in that particular. Now during this time the thread will be in the waiting state only, and it will not execute a single line of code, or any action will not be performed. Now this is one of the common ways of creating a delay in a single thread, right, or a threads where we are dealing with threads, and other threads are given opportunity to execute. However, but if you understand what happens internally, right, it is if going to affect the thread execution flow, and it has got certain limitation. Okay, now the syntax is like there are two variations. One is the common the sleep method along with this long millisecond. The other variation is having the milliseconds along with that. Now, what did I mean when you do work with sleep, right? Now, it is going to call the thread dot sleep. Now, it is going to pause it the execution. So, one call that is happening, it will execute and enter it into that waiting state. Secondly, the thread state will change from to waiting state for a certain time. So, in that time, it will not consume any resources. So after that, wake up the specific time. So after the specified time has been completed, okay, the thread will again move to the readiness queue, and it will become eligible for execution. Okay, so the scheduler will decide that. After the interruption handling, so basically if a thread is interrupted, let's say the thread sleeping thread, okay, via interrupt method, there is a method, right? The sleeping thread will immediately throw an interrupted thread exception. Now this is must be make sure you are writing this particular thread inside a thread try block, so that it is going to handle that particular exception, or the convert a calling method can handle it. Now what happens inside it is that internally, as I mentioned, when we call this particular method, is going to uh, interact with the thread scheduler of an OS, right? So OS is operating at the thread level at the different processor running at a different, right? So and the JVM is involved here. So the first of all, the thread state is being, when the thread method is called, sleep method is called, it enters into the wait state we already discussed. Second, like the JVM is going to communicate to the OS, which is going to handle your actual scheduling process of that particular thread. Now it may impact in certain conditions, like because it has got lot of scheduling mechanisms happening inside. Now the duration of that particular sleep will can be in the milliseconds or nanoseconds. However, this will have actual times maybe little bit varied, because of certain constraints, like JVM and OS have the additional load or resources which are like thread scheduling precision is there, like there are some different factors like OS load, system time, granularity, right? So it will check on based on that, and it will execute. Thread interrupt. Now if a thread is interrupted when it is going to the sleep mode, the JVM will wake the sleeping thread method, and it will throw the interrupted exception. So this has to be very properly handled, or it has to be either be propagated to the calling method, so that it will not terminate. Now you can also reschedule once that set time is executed. You can become eligible for the execution. However, it does not mean that the thread will immediately resume its execution. So it will depend on the thread scheduler. It will decide which thread will run depending on the different factors like their priority, what is the priority of that particular thread, and what is the availability of the CPU. So precision, the exact duration can be little bit vary. Example, as I said, if I mentioned nanoseconds, but it does not guarantee that the moment the nanosecond is completed, it will execute. So it will based on the thread scheduler, it will execute. We already discussed, like when it comes to threads, it has got different when it deals in a different way when it is a main method, when it is a when you're running the concurrent application, right? So when you call this thread dot sleep, let's say from the main method itself, right, the main thread exactly, it will pause, and it will during that time, and no code will be executed. So there is a delay. But in concurrent application, when thread application is called, it is going to sleep, and other threads are going to execute in there. So one thread is must be in the sleep state, but other threads are not. They are in the running mode only, right? So they can continue executing their threads. So in this way, they are going to achieve the multi-threading task. Now, what is the difference between the thread and the runnable? This is an age-old and it is a compulsory question which you should master, because this is the basics. And actually, if you don't know this, then definitely you won't be able to crack that. Okay. In Java, like we have two ways of creating threads, right? When you're dealing with multi-threadings, so you need to understand this particular difference, right? So how to use it, what are the design, what is the purpose of it? Okay. So the thread class is basically a part of the lang java.lang package, but it is going to represent that execution of a program. Now it is going to be created with the help of the thread class, and it is going to be extended from the thread class. Okay. So the important point when you are saying that about the thread class, right? It is going to be the class have that created, and then you're going to directly extend it. Now when you're creating in the thread and directly extending the thread, you're going to inherit all the properties in the behavior, so you'll get all these thing details. This means that thread can override the particular run method, and it can define their own task in that particular thread which is going to be executed. Now, control over the thread, if you look at this, it has got more granular, and the different states can be accessed, right? Now, there are different methods like start is there, sleep is there, join is there, and there is an interrupt method as well. So we can make use of it. Now, this is an example which we have given, like how we can create a thread using the thread class. Now, if you see here, there is a override method run, which is being written over here. And then if you see, there is a main method which is going to start that. So here, once you call the particular start method, it is going to execute and then run it. So overriding that particular run method, and then it will have the particular task executed in that whatever it is written in the run method. So always write the logic inside it. Now, runnable interface. This is an interface, I would say, functional interface, more specifically, which is going to represent that your task can be executed by the single thread, right, or a thread. So, compared to thread class, it has got more flexibility, and it is one of the preferred way of defining your thread to be executing the code, right? So, when you are dealing with the modern uh, way of writing it, right, and also the preferred way, the runnable implementation is the best way. So because Java supports composition over the inheritance, so this is also one of the better way when you're dealing with the pattern. So now one of the disadvantages, or the one of the advantages, I would say, is that there is no need of inheritance. So now you're directly going to implement that, and then you write your logic in that particular method over there. So you're not extending anything. You're not restricted. You can actually have a feasibility or flexibility to extend another class which is required, right? So that's the benefit. Now another thing is that there is a separate when you're using runnable, the separate task is written, the separate run method is written, and then you can execute that particular code. So this is much more flexible and modular. And the management of thread, when you're dealing with the interface, right, it doesn't is going to manage your thread. It is going to be, like, I would say, it is only the task it is going to be represented, right? So the thread is going to be passed to the runnable object and to thread object, and then it is going to be started and worked around it. So here is an example, like previously where we had created a run method. Under that we are going to run it, right? Here if you see that the run method is written, but actually if you see that the runnable class has been written, and then we are trying to run our task and then start it over here. Now the if you look at this particular thing, it is going to pass that particular runnable method to a constructor over here, right? So see here, that's a difference, and then it is ultimately going to start that particular method. Now I have written the differences over here. Please read it. Now moving on to the intermediate question. So far we have discussed the basic questions. Now let's move on to the advanced questions, or the intermediate, I would say. Now, what is the significance of Executor framework? Now, you must have already heard of Executor framework. This is an about the replacement of manually executing threads and managing your threads very individually, right? So this is a replacement for that. This was introduced in Java 5, and it is part of the Java util concurrency package. So it is actually designed to handle your execution of task in a synchronous way. Okay, and it is quite efficient, and it is better managed. So executor interface and its related classes are, we'll discuss further on that. There is an executor service, thread pool executor, thread scheduler, executor service, right? So these are significantly improved way, and this classes has got benefits when you're trying to manage, or it has got more flexibility when you want your threads to be scalable and easier to handle your concurrent tasks. Now, the benefit is that simplification of threat management. Now we already discussed by using this executor framework, the developer or the person who is going to earlier used to manually create the instances of the thread, or used to implement the particular running interface, are saved. They are going like they had to deal with starting, stopping, managing the synchronization process. Now this was quite I would say cumbersome, difficult, and error prone. So when you're dealing with multi-threading, so executed framework comes as an savvy, where it has got simpler way to execute that particular code in a synchronous way, and internally it is going to handle your thread cycle, life cycle management. Okay, so that's the better way. Now we'll discuss one by one the all the internal components. One with the first one is at the top is executor interface. This is one of the simplest interface, and it is going to have only one single method, that is execute method. It is going to accept the runnable command. Now whatever the task you want to execute, right, it can pass it, and it is going to be executed in a asynchronous way. Okay, now this interface is not going to manage your lifecycle method, but it is going to execute your I mean to accept that particular task and then execution under the executor. Now executor service is an interface which is going to which is a sub interface of that particular executor. Now it has got additional methods, like to execute the life cycle of the method. It has got a task to execute it, right, to handle it basically. So one of the important, or some of the important methods are submit. Now this is one of the method which is going to submit your callable or a runnable task for executing and returning the feature objects. The feature allows the caller to check if the task is completed, or it is cancelled, or it is going to retrieve the result. Now there is a features variation of that, and then also with the uh, it is going to accept the runnable, also the callable. Okay, but there is also a method called shutdown. Now this is it is going to initiate a shutdown process of that particular process, and it is not going to take any new task. Okay, so that's the indication when you call this particular method. Now shutdown now is attempting to stop all the actively executing thread. It will halt the processing for the waiting task, and it will return the list of the tasks that are waiting to be executed. A threadput executor class. This is most commonly used for as an implementation of executor service interface. Now, if you want to manage your pool of work of threads to executed, the task submitted task, right? It is going to provide you a very extensive configuration. So to control the threads as they are created, reused, and managed. Executor interface. Executor service. This interface is going to extend the executor service. Now this is going to provide certain tasks to run those particular in a delayed or a periodic manner. Now this is going to I would say very useful when you are using the task to be repeated, or let's say executed about certain delay, right? In that case, when you want some scheduling at a periodic time or a periodic task, right? So this can be done. Now schedule method we already discussed, there will be a delay. Schedule at a fixed rate, it is going to delay at a certain fixed time. Now schedule with a fixed delay, so it is going to be task to be run with a specific delay when there is a in between the execution basically. No, the advantages and the significance of this is that we already discussed thread pool and the resource management which is going to be happening. So it is quite, I would say, efficiently managing that particular thread is going to you reuse that particular threads. It is going to customize, like, your thread pool, so that you can dynamically adjust according to the workload. Okay. Better task scheduling and the control. Now if you go to that particular, let's say, the specific schedule executor service, this can be executed at certain interval, or at a regular interval, or at a fixed delay. So there will be a need of, it is going to eliminate your manual intervention or manual, like earlier we discussed, right? Thread dot sleep, or let's say the timer. So it is, there was a manual process we need to execute, right? So it is handled in a better way. So the task can be executed in a certain delay and fixed interval, and you have an opportunity to easily cancel, or check for the completion of that particular using the future object. Also separation of task submission. So there is a different decoupling which is going to happen. So separate thread, a separate mechanism is going to execute that particular thread. There is a different start task scheduling basically. So you can actually submit multiple tasks and execute it. So the executor service is going to handle like their execution, their scheduling, their life cycle, everything. It has got a better improved, I would say, error handling process. Now when you are trying to execute any task, and the error and exception in this particular are captured very efficiently, they will report using the feature object, and it is going to be easy when, when you're dealing with the error handling. Okay. So in the task itself, we are going to provide this particular benefit. Now, when it comes to scalability, there are dynamic thread pools which can be configured so that it can grow and shrink based on the system load or the resources it is requiring to execute that particular requirement. Okay. Now, simplification of the concurrency. Basically, the thread lifecycle, as I already mentioned, it's quite efficiently managed. Like, there are different lifecycle, like creation, waiting, and the termination, etc. Now, I've given a basic example over here. So if you see here, there are different. I've created fixed thread pool of three. Now I've written the submitted task, task one, task two, and task three, and ultimately I'm going to shut down that particular things, right? Now, when it comes to producer consumer problem, this is one of the important. I would say you cannot miss this particular question, because this is definitely been asked, and also when you're dealing with multi-threading, right? So it is quite important. So here he has asked about, like, how do you implement it using the wait method or notify method, or he may ask you about when to implement it, right, using the blocking queue. So either option you can say, but you have to know the both the problems, right? What exactly the actually the producer consumer problem it is, and how you can solve using this particular two mechanisms. Now, consumer mechanism, or a problem, I would say, is one of the scenario where multi-threading, the two threads which are going to be it will execute in such a way that the one is producing and one is consuming the data uh, in a very sorted way. So the problem occurs when you have some limited resources. Let's say you have some problem with the shared buffer, where you have some queue. So you need to ensure that it is going to produce that particular thread and add that particular data to the shared resources, like, or consume the thread which is going to consume the data from the shared resources, and the system has got a proper way of synchronizing that particular shared resources. So it is going to avoid your race conditions, or there is an inconsistency when you're trying to pull the data or push the data, right? So the proper synchronization must be in place, so that this is going to add some data. Let's say it should not happen that producer is trying to add the data even the buffer is added full, and also it should not also happen in such a way that consumer is trying to consume the data even though there is an empty, the buffer is empty, even though after that is trying to consume that. There is no point of that. So you should properly handle this particular scenario. Now we'll look into how we can implement this, right? So the problem, we already identified that the producer is going to produce, consumer is going to consume, right? So we'll look into how we can deal with when it comes to manually. That is, first we'll discuss about the wait and notify in the manual approach. Then we'll discuss about the the better way, that is blocking queue. Now, wait and notify, we already discussed about the notify. It is going to wake up all the threads which are the single thread which is going to wake on that particular object, right? So now when you're dealing with this producer consumer problem, you have to make sure that you should be well aware of the particular concept of wait. When do we use wait? When to notify call? When to notify like when you're doing the inter-thread communication, right? So typically, when you're trying to implement your low-level synchronization between these particular threads, right, we use this particular wait, notify, and notify all method. So these are all the objects which are belonging to the object, because these are all the methods which are defined in the object level. So this is going to give you a much more control when you're trying to execute. Okay. So wait method is going to, you already know, it is going to cause the current thread to release that particular monitoring whatever log it had, and then it will wait the waiting status. Okay. So it until, like, when you are calling this particular notify on that particular same object, until that you will not be able to execute that. Then notify, we already discussed, it is going to be wake up that particular single thread which is all currently waiting on that particular object. Notify, it will wake up all the threads. Okay. So in the producer consumer problem, the producer is going to wait if there is a buffer is full. Okay. So we have to accordingly implement. When the buffer is full, you have to call the wait method. Now in consumer, it will call the wait method, but when you have to call the wait method, because if the buffer is empty, because if it is empty, then why need to consume it? The producer will definitely notify the consumer if the item is added to that particular buffer, so that it can consume that, right? Now the consumer will notify that if there is an uh, it has consumed that particular item from that particular buffer, so it has to indicate that one thing is consumed to the producer. Now here is an example. If you see at the buffer, I've created an int buffer of 10, and then if you see the logic of that particular method, the produce method, it is going to produce an item, and then it's going to add into the buffer. Okay. And if you look at this, I'm going to check at the condition whether the length is same. Then I will go into the wait state, or else at the end it is going to notify it. Similar logic is written in the consume method, where it is going to check if the length of the buffer is empty, then there is no point of executing, right? It will wait, or else it will try to notify that particular thing. So like after it has been consumed. I hope this example is clear. Okay. So the buffer, actually we already discussed, right? So it is going to consume from that, and then it is going to produce, and it will notify. But now the second way is that blocking queue. Now this is, I would say, a better approach, a very much more modern and the higher level of abstraction is, when you're dealing with threads, right? So it is going to solve your producer consumer problem. And if you go with, like, blocking queue, it is better way to handle the thread safe way, I would say, to handle the queue. So the operations like put, it is going to put some element inside it. We have take, which is going to consume the element, or which is from the blocking state, right? So these are all method which is going to handle your waiting and notify automatically, so you doesn't need to manually call that particular uh, wait and notify methods, right? So it will automatically take care of that particular flag. So this method is, when you call put, right, this method is going to be acting as a producer, and it will if the block is in the queue will full, then until that space is available. So take, this is method is used to consume it. So it is it's block whatever that is going to there, right, is going to be empty then until that item is available. If you look at this particular interface, it has got different implementations in the star library, right? So we have array blocked queue, then it has linked blocking queue, it has got priority blocking queue. Based on your need, you can use it. Okay. So since we are making use of this particular here over with that, now if you see that there is a run method, but before that we have defined a blocking queue. So it will check for that particular in the constructor, and then it will look for that particular queue to be put up. So it is going to blocking that particular call till the wait method, wait if the call is full. Similar way, the it is going to take or pull that particular blocking queue until the wait if the queue is empty. Okay. What is the difference between callable and the runnable? Now many people are confused and they are not aware of this, like how and when should we use it, right? uh, so these are all the interfaces only, but they are executed in a different purpose, and they have got different I would say functionality when it comes to the usage. Callable interface, when we are discussing, it has got a different return type. So this primary difference is that callable is going to return something as a result. Okay, so this is one of the difference when it comes to callable. Now, callable method is going to throw an exception, like when you are compared with the runnable, it will throw an exception. So this is going to be more flexible, and you can also catch the exception in the call method. Now this method, if you see, you have to look at the syntax, right? It is going to be a we call exception, right? It means it is going to return something as a result, that is, and also it can throw an exception. Now when do we use it? When you want your task to return certain result, or let's say expect some task to be executed to throw some exception is thrown, right? Typically we use that. Okay, so executor service is going to call when a callable with the executor service, we can actually return certain feature object. So it will return the result also, and if nothing is written, it can also handle your exception that the task is completed. Runnable interface. This is one of the, I would say, which is not going to return anything. Now this is simply a void method. It is going to simply perform the task and it will complete it. That's it. Now you have no way to throw or any sort of checked exception or unchecked exception, like how it is going to be handled in the call. But this method is purely a void thing. It does not return any value or result the task once the task is finished. So typically, when you want your task to be as simple and run the code in a separate thread, you make use of this particular thing. But let's say if you are not does not care about your task is completed or not, you doesn't want the result to be returned up. In that case, we use this particular exception. Now we already discussed the runnable when to use and callable when to use. So this is how we on the need basis we can use this. Now let's move on to the advanced level questions. What is fork join pool in Java, and how it is different from the normal executor framework, right, service? Now this is a specialized implementation of an executor interface, I would say. So it is typically designed to handle your tasks that are divided into a smaller, and then you can execute that particular subtask, right? So which can be executed concurrently and in a parallel way. Now, ForkJoinPool is part of the Java util concurrent package, and it is one of the optimized way of running and dividing and conquering algorithm, right? So this is going to make your last task into a smaller task so that it can be executed in a small steps. The benefit or the key feature is task decomposition. Now we already discussed that for giant pool is going to split your task into different several independent tasks, so that one subtask can be broken, and then it can provide the result as and when it is required. So the key is it is going to break down that. Now stealing work stealing, but I mean this is a technique when we call you know. Where when the one thread is trying to let's say if it is has got one task, right, it has finished its task, then it is going to take the other thread's task which is heavily loaded, or it is not able to execute because of the already existing task it is being executed. So it will pull out that particular task from that, and it will work on it and finish that particular task. So it is one of the better way to solve this, where the resource is overly loaded. It is optimized when it comes to parallelism. So the tasks that are in the recursive and the running the parallel processing. So it is going to divide that and then conquer the algorithm it is going to use, that is divide and conquer. So where, like, we have merge sort, quick sort, or there is a parallel stream operation which is using that, right? It is going to handle it in a very efficient and optimized way. Now, the usage of this particular thread should be efficient, right? Now, when it comes to ForkJoinPool, the small number of threads as compared to the very big task, right, or a normal thread, this is going to be quite more memory efficient, right? It is going to deal in a smaller, I would say, things which will be easy to handle it. Okay, so this is designed in such a way to work very efficiently. Now, we already discussed like what is the difference when it comes to fork join, pool, and the executor framework. There is a difference when it comes to task decomposition. So in normal task, the task is not broken down. It also, like, work style, like, it is not going to take that task which is already assigned to a different task and then start working, right? So it is going to, the difference when it comes to the normal thread and then fork join and pull. Now, execution model, basically it is going to divide in the the recursive way, it is going to divide that, and then it is going to handle that particular task. So the method is like, if you use this particular join for a task, right? So it is going to be running in the recursive task or recursive action. So this will break your task into smaller part and also synchronize their results basically. So the best way is using the independent task which can run in the parallel way. So in a small parts basically. Now, when to use this particular fork join? When you want a recursive and also the smart, you can, your task is manageable and split it into the subtasks. So in that case we use, and let's say you want your performance to be increased, and for that, in the you want a much scalable way of processing some, or into numerically process or compute something, we can use this, right? So this has got a benefit. When you have the particular task is been overloaded, it can take that particular and then take the load of that, right? So in that case we use it. But when it comes to executor framework, it is one of the general concurrency task execution, especially it is not recursive, I would say, when you compare it with the fork example. And when you have that particular pool size defined for this executor framework, so there is fixed pool. So this is not happening with the fork pool. But when it comes to IO bind task, other task during the parallelism, we can take we the IO bind task basically, or the cases where parallelism is needed. This cannot be the recursive, I would say. Now, what is deadlock? What is the concept of deadlock and how you can avoid in multithreading? Now, this is uh, definitely a question which is definitely asked. You should be well prepared of it. Now, what is deadlock? Basically, it is in the multithreading environment when two threads are trying to block the it is going to be blocked forever. So basically it is in the waiting state for other thread to release it, also to uh, so until that, it is not going to proceed. So when it happens is that when a thread, let's say thread A is there, okay, is going to hold a lock on that particular, let's say, resource one. Now uh, it is going to wait, or allow to other threads to wait, let's say the resource true, right? So in similar way, let's say resource thread B, it is going to hold back on the resources 2, and it is going to wait on the resource 1. In this way, there is a circular dependency among these two. So the another thread is waiting for the release of the another thread, which is neither going to happen because it is going to block it. So this neither of this particular thread will execute it. Okay. So how you can avoid this is that you can actually have a lock implementation. So the concurrency package has got a way to handle this, right? So first you have to acquire the lock in a consistent and a predefined order. Second, you have to ensure that thread will never be ending up in a waiting state for other thread indefinitely. So let's say if a thread A is always in the A is always locked up the resources one, right? Before the resources two. So that, and thread B allows the same order, same feedback, the deadlock can be avoided. Okay. So we can make use of the try lock. So it's part of the reentrant class, okay, lock. So which has got a try method which is going to acquire a lock without blocking the other threads indefinitely. So if a lock is unavailable, the thread can give up, and or it can retry after some interval of time. So which will prevent the deadlock. So it is not going to till the life it is going not to be locked it, right? So that's the benefit. Now if you see a re-enter log 1 and 2, it is going to first check the try lock can happen or not. Then only it is going to enter that particular section and execute it. Now, if you when it comes to deadlock, right, the timeout is quite important. So we have to first acquire the log. If the thread cannot obtain or acquire for a certain period of time, it has to back off, and it has to try off again after some times. So this will reduce the chance of deadlock. Second, there is a nested lock, so it will always minimize the number of nested locks you need to apply, right? So it is a better design of a program where you are avoiding your multi thread. One thread is going to handle the lock situation in very simultaneous way. Now it is going to detect periodically where the condition can occur. So even though it is quite complex and it has got an overhead, but it is going to determine that particular deadlock situation for you. I hope this particular video was very helpful and it will give an insight of what kind of questions are asked in an interview. Thank you for watching.